Hey everybody, we're going to be starting Unit 7 today. Sorry for the delay on these notes, but here we go. You will need a calculator today, preferably a physical one if you have one. If not, that's fine. You can use the app that we got on the phone. Okay, here we go. So today we're going to be looking at two major things, and I'll probably be splitting this into two videos just as a heads up, but I'm going to try to squeeze it into one. So the first thing we're going to be looking at is what we call parent functions. Parent functions are functions that are the base function with nothing fancy happening to them. So for example, when I'm talking about a square root function, all I'm talking about is square root of x. Nothing fancy, nothing crazy going on here, just square root of x. If I'm talking about a quadratic, I'm talking about x squared, again, no addition, no subtraction, no multiplication, no division, no nothing else, just a square. Cubic, x cubed, and then absolute value, okay, like that. Now, we want to take some time and actually create these functions. So to do that, we're going to do that in the calculator. We're going to take a tools-heavy approach to this section of this unit. So starting out, we want to go here. We want to turn on the calculator. Okay, now yours may look a little different from mine if you have the 84 version. Okay, but for the most part, it's going to be looking the same. Okay, now real quick, make sure you write this down. To reset a calculator, you hit second plus 712. Okay, and that's going to reset your calculator for you. Go ahead and write that at the top of your page because it's really not fun when you're in the middle of a test and you're trying to do these graphs and it's not working for you. The fastest fix for most problems, in fact, all problems, is going to be that. There are some other fixes that don't erase everything, but unfortunately, that's just the catch-all that works for everything. Okay, so if we look, we don't have a square root button on our calculator, but we have this little square root right here. On your calculator, it will be blue on the 84s. So to get that, we're going to hit second squared, and then x is right here next to the alpha. Okay, and there we go. We can graph that now, and it looks like this. Okay, it kind of looks like it goes through 0, 0, maybe goes through 0, 1, and after that, I'm not really sure. So to be sure, what we can do is we can hit second table, or second graph gives us the table, and I can see the table of values here. Now, if I scroll up, I notice that I don't have any negatives, which makes sense because the square root of negative numbers is bad. But I have 0, 0. I've got 1, 1. 2 is kind of a gross number. Let's not deal with that. 3 is a gross number, but 4 is also negatives. So in Math 2, you only need 3 points. So we're going to use 0, 0, 1, 1, and 4, 2. Okay, in Math 3, you will need more points, but your teacher will tell you how to get those next year. Okay, now, if I plot those, I get this, and then I get something that looks like this. Okay, now this 0, 0 is what we call a critical value, or in this case, a starting value. Okay, that's going to be an important value that we'll talk about in a little bit, but that's one we want to start with there. Okay, for x squared, we're going to repeat the same process. Go y equals, we'll clear this out, x squared. We'll graph that, see what it looks like. Hey, it's that U shape we've been dealing with all year. Okay, we also notice that this one probably also goes through 0, 0, but we can verify that. And in fact, it does, 0 and 0. Okay, so our critical value here, or our vertex in this case, it's going to be 0, 0, 1, 1, and negative 1, 1. Okay, now again, in Math 2, we only need 3 points. You will need to do more points next year, but your teachers will let you know which ones to use. Okay, and then we just need to remember that this is U-shaped. So negative 1, 1, 0, 0, 1, 1, and then I get a nice U shape going. Okay. Repeat the same process for cube. Let's go to y equals, clear this out. Now this is where yours is going to look a little different. So we're going to hit that X button, and then we just see that there's not a cube button here. So we're going to use this little caret icon. Now on your screen, it's actually going to put it up on the top there. It's not going to write the caret like it does on mine. It'll actually look like x cubed. Go over to my table because we found that was more useful. We find that we also go through 0, 0 here. So 0, 0, -1, -1, and 1, 1. Which if I plot those points, gives me this, which kind of looks like a straight line. Now let's just verify that by going into our graph. And we find it's not. Okay, we got this nice curve going. So let's draw a little curvy here. I like to call these my squiggles. Okay, so x cubes are always going to be squiggle lines. Okay, with again, this being my critical value. In this case, it's called a point of inflection. Okay. Absolute value of x. Now this one's tricky to get to. So write this down. You're going to hit the math button. You're going to hit the right arrow. And then you're going to hit enter. That's going to get you absolute value. Now again, on your screen, it's going to look really nice and neat. On mine, it doesn't. So I hit math. It's right under alpha. Hit the right arrow. And then ABS is the one we want. And then x. So yours will look exactly like the x squared there, or the x inside the absolute value bars. Okay, mine looks like this. Same idea. Okay, got 0, 0 again. Yay, that's really nice. -1, +1, 1, and 1. Okay, with this being a vertex again. So I plot those points, and I notice that it looks the same as my x squared points. Well, if I look at my graph, though, it doesn't look the same as x squared. I've got nice straight lines. Okay, so this is the difference between this and x squared. Absolute value, we've got V-shaped. Okay, so there's the parent functions. Now, as far as the transformations go, so we're going to take these parent functions, these graphs, these basic graphs, we're going to stretch them around, we're going to flip them over or reflect them, we're going to move them around, but they all come from this. Every single absolute value comes from this guy. Every single cubic comes from this guy. Every single quadratic comes from here, and every single square root comes from here. Now, we need to talk about these transformations. So we've got this big, nasty formula that we'll go through in a little bit. Okay, but each of these little parts does something to a graph. So let's talk about those individually. So first, we might have something where there's a number out front, something like 1/2. And we're just going to do x squared for all of these to keep it the same. So I know my parent function looks something like this based on what we just did a second ago. Okay, well, if that number out front, in this case a, is less than 1, meaning we have a fraction, something like 1/2, 1/3, 3/4, or a small decimal, 0.3, 0.4, 0.25, okay, then that will be true for these guys. And what that's going to do is it's going to shrink, vertically by whatever that number is, in this case, 1/2. Okay, so think about it like a hula hoop. If I take a circle, okay, and I squish it down, then these sides are going to come out. Okay, meaning I'm going to have something that looks like this, where it's stretched out a little bit, or sorry, squished out a little bit. Okay, now conversely, I can have a being a big number, bigger than 1. So something like 3. Okay, so my parent function still looks like this. Okay, now in the other direction, again, if I have that hula hoop and I stretch it out, then these sides are going to come in a little bit. Okay, so instead of looking like this, it may look something like this. Okay, so we get a stretch vertically. This is my transformed. Okay. Now, this one, we're not going to worry about in Math 2. You'll get to it a little bit in Math 3, but it's not something we cover in Math 2 regulars. So don't worry about this one. The negative out front we do care about, though. Now, I want to be very clear because when I'm talking about the negative out front, I'm talking about a negative and not the number. Okay, so we'll look at an example later. Well, what if we have something like negative 3x squared? What happens? Okay, and what we're going to find is this negative and this 3 are separate things. Okay, they are not the same thing. We don't want to ever bunch them together as a negative 3. It's a negative and a 3, not a negative 3. So they are two separate things. Okay, so right now let's just look at the negative. What this is going to do is we're going to go from our parent function, and then it's going to reflect it down. Over x. Okay. Now you're gonna you may hear me say flip. I'm sorry, that's just a bad habit. If I mention that in class, your Math 3 teachers really want you using the word reflect. It's the better math term, and it's really what is happening. Okay. Now k. So if we have a number outside the parentheses, so like x squared plus 3. So again, parent function transform. Okay, this is just going to move it up 3. So it's just going to shift up by whatever that k value is, in this case 3. Okay, conversely, if I have a minus, so x squared minus 4, again, parent function, we're going to go down. So it might look something like this now. So shift down by 4. Okay. Feel free to pause at any point too. I always forget to mention that at the beginning of the video, but if you do need to pause, feel free to pause. I know I go somewhat quicker in the videos. Okay. As far as left and right, that's on the inside. Now, this whole time, remember when we talked about vertexes in the past unit? So this is not part of this unit, but this is like last unit. We had something like this. And then I would ask you, what is the vertex? Well, the vertex here, we took this number, we changed the sign, we took this number, and we kept the sign. Okay, well, that was nice and neat, but we never really talked about why this is. Well, this is why. It's because it's a minus here, okay, on the inside. And anything with x is always going to do the opposite of what we want. So if I have x, in this case, minus 3 quantity squared, again, parent function. And then the minus, again, we usually think of that as left, but since it's with x, it's going to do the opposite, and it's going to go right 3. Okay, so minuses are right shifts. Okay, whereas positives are going to be left shifts. So like x plus 2 quantity squared, again, parent function, it's going to move left 2. So shift left. Okay, and these are the 8 things that can happen. Really 7 we're going to worry about this year. You can have that negative on the inside, but you'll talk about that next year. Okay, so let's break down each of these parts here. The negative here causes a reflection over x. Okay, the a causes a stretch or shrink. Shrink. I can't spell. Shrink. There we go. Okay, the stretch is if a is greater than 1. The shrink is if a is less than 1, or those fractions. Okay, or small decimals. Okay, now again, these are 2 separate things, and we'll look at an example in a minute. But if I have a negative 3, it's not a negative 3, it's a negative and a 3. Okay, again, this negative we're not going to worry about. What it does do is it does flip over y, but we're not going to worry about that. So this is a shift left or right. Okay, but remember, left is positive, right is negative. It's backwards of what we want. And then last, K is a shift up or down. Okay, this does do what we want, positive, negative. Okay, continuing along. Okay, so how do we use this? Well, first off, what we want to do is we got two big skills. First, we need to identify the type of equation and its transformations. And two, sketch that graph. Okay, so very first thing we always want to do is what equation is this? Well, I know it's a quadratic because I have that squared. So I know my final answer should be U-shaped. And if it's not, I did something wrong. Okay, now let's talk about the transformations. Transformations, the best thing to do is work from left to right. So start with the negative, then the A, then the H, then the K. Okay, so on this one, no negative out front, yay. No A out front, yay. Okay, so my first number I come to is the 3. Well, the 3 is inside with X, so I know it's a shift left or right. And in this case, it's going to be left. Okay, again, I know it's a positive, but because it's inside with X, it does the opposite. Okay, the 2 we already identified, that tells us what it is. And then the minus 5. Okay, which is a shift down 5. I'm doing a video. I need to finish this. Okay. So we have a shift down 5 here. Okay. Now, we need to figure out what our star numbers are here. Okay. To get that, it's going to be that vertex here. Well, my vertex is -3, -5. Okay. Now, to get the other ones, the best way to do this is to go back to the calculator. And we're going to type in this equation. So parentheses, x plus 3, close parentheses, squared minus 5. Okay, and graph. So I want one on the left, one on the right. So I want -4, so I'm just going to scroll up. -4 is at -4. -2 is also at -4. So -4, -4, -2, -4. So I plot those points, 1, 2, 3, 4, 1, 2, 3, 4. And there we go. And then I've got a U shape. Okay. Now, once you get to this step, we need to think about this logically for a second. So we said it would move left 3 and down 5. Well, if my original started here, because this is where my parent function would be, I move left a little bit and down a little bit. So yeah, that makes sense. Okay, so on these, always double check. If you don't end up where you're supposed to and your graph doesn't match up, you did something wrong. And we can even graph this to see, hey, yep, it did move left and down a little bit. Okay, same idea. Now I've got a number out front though, so we're gonna start very first, it's a cubic. So these are our squiggles. That number out front, that 3, is going to tell us we have a stretch by 3. Okay, the 2, again, plus, but it's on the inside, so it's going to do the opposite. So we want to go left 2. And then the 4 is down 4. Okay, so there's my description. Okay, again, which is one of the big parts. Okay, now this one doesn't technically have a vertex. It has that point of inflection, but again, we can think of it as that star number. We get it the same way. We take the inside number, we swap it. We take the outside number, and we keep it. Okay, now your calculator is going to look very different from mine here. I apologize for that, but there's no way for me to get an 84 on here. So we're going to put 3, parentheses, x plus 2, close parentheses, caret. Okay, and on your screen, again, it's going to put that number up there for you, and you're going to put that 3 up there. Oops. Okay, and then for you guys, what you want to do here is you want it, because it's still up there with that 3, and we don't want it to be anymore. So if you hit the right arrow, it'll bring it back down for you. And then we push the -4. Okay, so if yours looks like exactly like we started with, you're good. If it doesn't, if it looks like this, then you didn't hit that right arrow because it's putting everything up top, and we don't want that. Okay, so I go over to my table. I want one number smaller, one number bigger. So -1 is going to be at, or sorry, -3 is going to be at 7. -1 is at -1. It's -3, -7, -1, -1. It's -3, 1, 2, 3, 4, 5, 6, 7. -4. And again, we don't want a straight line here. We want a little bit of a curve. Okay, just give it a little bit of a curve and you'll be good. Okay, 2 more. Okay, so this is the first one where we have it where we have to be really careful about that negative and the number. So first, we know this one is a square root. And it's going to look something like that. Okay, the negative out front. Again, it's not a -1/2. It's a negative and a 1/2. Okay, so the first thing that's happening is the negative. That's a reflection over x. Okay, the 1/2, not a -1/2. A 1/2 is smaller than 1. So we're going to have a shrink by 1/2. Okay, continuing right. 4. Inside with x. So we're going to have a shift left 4. Okay, so we find the starting point in this case, not a vertex this case. We find the starting point the same way. Okay, we're going to do the inside, -4, switch sign. I don't have anything outside, that's fine. We can add 0 to something without changing it. So there's my starting point. Now, if I think back to my square root parent function, it was a little bit different. These ones we used the number and 2 numbers on the side, but on this one we used the number and 2 numbers after. And that's because it only goes in one direction. So we want to be really careful when we choose our numbers here that we're picking nice numbers. And we also had numbers that weren't very nice sometimes. Okay, so let's go in and graph this. Again, yours is going to look a little different from mine. It should look almost exactly like this. So -1/2, fractions are just division. Square root x plus 4. Second table. Okay, so there's that -4, 0. And if I go up, I see I don't have anything up there that works. So I want to go down. Okay, I could use this -0.5. It's a nice number. Let's just try to use whole numbers. It's usually just better. So 0, -1, and 12, -2. So 0, -1, and 12, -2. Okay, so 0, 0. Sorry, no, not 0, 0. -4, 0. 1, 2, 3, 4. And then off the page a little bit for this last one. So I get something that looks like this. Okay, now you're thinking, oh wait, hold up. It's supposed to look like this one up here, but it's going the other direction. Well, it's supposed to. We've got a reflection. Okay, it's squished down a little bit. It's not quite as fat. And then we've got it moved left a little bit. So we're good. Okay, last one. I want to change this one a little bit to -3 x minus 2. So same idea. We're going to start with that negative first. Negative tells me a reflection. Oh, sorry, I should have identified first. This is an absolute value, meaning we've got V-shaped. Reflection over x. Sorry, I was trying to make sure I squeeze this video into the time so YouTube doesn't get mad. The 3, not the -3, just the 3 is bigger than 1. So we've got a stretch by 3. Okay, and then the -2 is going to be a shift right 2. Again, it's always the opposite. Negative feels like it should be, left, but it's the opposite. Okay, so my vertex, and this one does have a vertex, is going to be at positive 2. Change the x. Leave the y. Okay, go into my graph. So -3, math, right, enter, x minus 2, close parentheses. Okay, I want 2, and then I want the two numbers on the side, so 1 and 3 are both going to be at -3. So 1, -3, 2, 0, and then 3, -3. So I get something that looks like this, okay, which if I think about it, I should have started with this. I flipped it down, or reflected it down. I stretched it out a little bit, and then I moved it right too. Okay, so we're good to go there. Okay, if you have any questions, feel